So this is for the training effect booklet answers with explanation, this video. Question number 1 is showing this arrangement. So you have to calculate the weight of the beam. So clockwise moment will be something that will be going like this way. So 60 newtons times 30 plus 20, 60. And anti-clockwise moment will be the weight times 30 gives you 100 newtons. Which lamp is most stable? The lamp with the lowest center of gravity will be stable. So it is asking in this question, what is the size and direction of the force? So we calculate both clockwise and anti-clockwise moments like this. So we have 8 Newton producing clockwise moment, 12 Newton anti-clockwise moment, both at distance 2 meters. And X force is also producing a clockwise moment. So X will be added to the clockwise moment. These two will be added together, equated together gives you 2. And we have assumed that X is producing clockwise moment, so it will be acting upwards. So this one, we have to calculate the size of the force F. Again, we have 3 forces. This force is producing anti-clockwise moment. F is also producing anti-clockwise. So we add the 2 forces and then clockwise moment by 60 Newton, equated together, algebraic manipulation, and X gives 12. This one, again, we have a wheelbarrow whose weight is acting downward as 600, and that also includes the load. And the force F is applied to lift it. So the F is acting at 70 centimeters from the pivot and is producing anti-clockwise moment. And the weight, the load is producing clockwise moment. So we calculate these two, equate them together and get the value of F. Ignore this X, it is F, and F will be 350 newtons. In this question, we have to calculate the size of the force U. We have 3 forces, 1 and 2, they are producing clockwise moment. U is producing anti-clockwise moment, so we put the values like this, and then equate them together, and then calculate the value. And that gives you 2.5. So make sure you use the U distance as 40 centimeters from the pivot. The first thing in these questions is to identify where the pivot is. Second thing, how many forces are acting. Third thing, which force is producing clockwise moment, which force producing anti-clockwise. Calculate their moments like this, equate them, and then calculate this, the unknown value. So question number 7, a car is designed to be stable and its mass of center of mass has to be as low as possible. A man uses clay to make a pot. He wants the pot to be as stable. Again, the area must be wide and the height must be low. So these two features give the pot more stability. What affects stability? Base area and location of center of mass. This chair is most unstable because it is very high and its base area is narrow. Okay, these two are low. This one is high, but with a wider base area. This lamina has a center of mass at C. Just intuition. If you cannot do anything else, use your intuition and you will solve these such questions. This one, as you see, when we move the weight this way, the moment produced by weight will decrease, and hence the moment on this side will increase. So this moment will make the meter rule go downwards. Going it downward will increase the stretching of the spring X and decrease that of Y. So C is the choice. In this question, weight of the beam needs calculating. Weight is producing clockwise moment. this 5 Newton producing anti-clockwise moment like this. So equate them. So first calculate their moments, equate them, and then you get the answer as 2. This is the least stable because of its high center of gravity, center of mass, and less base area. In here, we need to calculate the force P, which is producing a clockwise moment. So 4 and P will be added like this, their moments, and the clockwise moment, anti-clockwise moment will be by 3 newtons, which is at 6 centimeters. So we calculate them like this, equate them, and P comes out to be 5. P is the most stable because of its wide base area. And here, well, first algebraic formula for their moments, y times s, x times p. So out of these, I can quickly see, don't use calculator here, please, you'll waste a lot of time. Just do the multiplication with the number and put the zeros at the end. So 12, so we have to do ys. So ys, 300 times 16, 4800, and then xp, 400 times 12, 4800. Both equal, so C is the correct choice. Here, the weight is hanged, and that's why it is balancing at C. If you remove the weight, it's going to fall this way. So that means its center of gravity, center of mass, is not any this way, it's actually this way. So if you move it here without the weight, it should stable. And that is the only choice we have. Here, we have 2 weights and a pivot. So if they are taken to another planet, they will still be the same because the mass does not change. The weight will decrease or increase proportionally. So their mass does not change. That is the key point here. C is most stable because of wide base area and lowest center of mass. This question here, we have a 60 Newton at 30 centimeters. If you have 30 newtons acting upwards, 60 centimeters to the left of the midpoint. So to the left of the midpoint, 30 newtons force acting upward at 60 centimeters should give you the same moment because 30 times 60, first thing you look for is 30 times 60, okay? And then you look for, well, ideally it should have been on this side, but then it should be acting downward. We don't have any choice that is acting downward, so this will be the only choice. Lamina, the choices are not given in this question, so just ignore this. If it pops up, I don't know what the question is, so we can't answer it here. If it pops up, just do your best. So, sorry, the question is on the next page. Yes. So he does all this procedure and then read it carefully. You will know that B is the correct choice. This one, it's the diameter and the position of center of mass, which makes it more stable. It is energy related question. In a electric generator, we burn the coil that is having chemical energy. It burns, gives heat energy. Heat energy is used to run the turbine, making the turbine giving kinetic energy. This kinetic energy is used to run the generator, which produces electrical energy. In here, there is a door whose hinge is acting as pivot, and the door is lifted upwards, and its weight is acting downwards. The two distances are given. Clockwise moment, weight times 30, anti-clockwise 15 times 30 plus 30, because this is the distance of 15 Newton force from the pivot, perpendicular distance. So calculate them, equate them, get the value. And then once you've got the weight, the mass will be weight divided 10, 3 kilograms. In this, the distance of the weight from the pivot weight of the rod from the pivot is 40. Use this distance, W times 40, clockwise moment. This force here, anti-clockwise, 44 times 10. Equate them, get the value 1 Newton. Here we have a tricky question. So we have two loads. They look different. Well, they look different, but they're not different. Why are they not different? Because of these words. Look at them. Balance is on a pivot. So these two are balanced. So they are producing the same moment. So these two moments should be equal arrows downward and an equal one arrow upward. This arrow is the normal reaction force, the contact force, normal contact force acting upward. This and this is their weight acting downward. They're both equal. That's why they're balanced. All other choices, the two arrows are not equal. Here, although these two arrows are equal, but this equal, so another learning point here. If you want this rod to balance, these two arrows should be added and they should be equal to this arrow. So here, these two arrows are added, but this arrow is not equal to their sum, whereas this arrow is equal to their sum. That's why this rod is balanced. The bus is just about to topple. What is the center of mass? Well, if you consider this here, this area, this is their base area, this here. So if this was the center, it's not going to topple because this is very far from the base area. This point, B point, is already gone over. So if this was the center of the mass, it would have been toppled over already. This same, so C is the point where the center of mass is because the bus has not toppled yet. Here, this is a tricky question. The weight of the lamina is acting downward from here, and this is the pivot. So the weight have a perpendicular distance from the pivot as QC, which is given as 0.3. So weight times 0.3. Weight is 2 newtons times 0.3 gives you 0.6 newtons, and this will produce a clockwise. So A is the choice. Lamina question, you know the center is here. This tricky question, well, we have 4 different rods. Which one is balanced? The one which is balanced should have the both moments equal. Calculate their moments. Make sure you look for the correct calculation. 40 times 40, but look at this arrow. This arrow means force is acting upward. So both forces will produce a clockwise moment. No balance. This one not equal, moments not equal. This one again, moments not equal. This one here, 10 times 0.2 and 5 times 0.4 gives you the same moments, and they're both in the opposite direction, clockwise, anti-clockwise. So this one is balanced. Here, a boy is sitting, 500 Newton weight, force F is applied on this side. What is the force? Well, just calculate the moments, equate them, and get the value 250. So if a nut and bolt are difficult to undo, it may be easy to turn the nut by using a longer spanner because a longer spanner gives a larger turning moment, turning effect actually. This question is not included. I have just highlighted the correct choice. This question is not in your curriculum, in your syllabus. This one here, a wheelbarrow having a 150 weight, and then a force F is applied. Force is at a distance 0.75 plus 0.75. Equate the clockwise and anti-clockwise. Force F is producing anti-clockwise. Weight is producing clockwise. Equate them and get the value. The B has the least stability because of its high center of mass, least base area. The tractor has a center of mass at D. Safest position will be at D to keep it away from toppling. So this one, so we have a force and its perpendicular distance. The line of action of force is this. The only perpendicular distance can be D. It can't be H, it can't be L. So F cross C is the correct choice. And the bird is balanced. What is the effect of the paper clips? The paper clips have moved the bird's center of mass down somewhere below man's hand. That's why it is balanced. If it wasn't there, the bird would topple on the left. Here we have a force acting in an anti-clockwise direction, and this is the pivot. Calculate this. Then the force acting this direction. So if you continue this line and take this perpendicular distance, it will be F times 5. We create them and get the answer.